Alright, so this is my final part 1 of a principle of physics demonstration experiment. And a few things that I'm going to be going over in this video from what we've learned in class is evaporation, boiling, heat transfer, and a few more things. And so basically for this experiment, all you need is a hand boiler. You can get them on Amazon or wherever else you want to. And what this is it's a sealed glass tube. That's all it is. And then there's just a liquid at the bottom, and this liquid is methylene chloride. I don't really know how to pronounce that, but anyways, so just for this experiment, you just put your hand right here, and you see the liquid travels up, and then it starts to boil. You can see that. You can kind of see that. And then when you put your hand on the top, it comes back down. All right, and so there's a few reasons why the liquid boils. So the first reason is because the liquid has a lower boiling point. So like for water to boil on the stove, you usually need about 100 degrees Celsius to make it boil. For this, the boiling point of this is just above room temperature. So that's why the energy from your hands, or the heat from your hands, can increase it and cause it to boil. And so what causes a lower boiling point is high vapor pressure. And basically what higher vapor pressure is just a greater concentration of gas. And since this is an airtight device, air cannot get out. And so it is sealed, so there's a higher pressure, which makes it have a lower boiling point. Another thing which causes it to boil is obviously just the temperature of your hand, because so temperature and pressure are proportionally, you increase the temperature, you increase the pressure. Same likewise. So when my hand increases the temperature, I am increasing the pressure in this tube, which causes it to boil. All right. And we know that the heat from my hand is creating it to boil, but if we look a little closer, we can get a little bit more of details. You can see there are little air bubbles in it, and that is actually the molecules in the air that are evaporating up. So when you add heat to something, what are you doing to the molecules? You are activating them, and they start to move, they start to expand. They obviously, like before, they just want to get out, but they can't because it's sealed, obviously. And so all boiling is, and evaporation is just energy. It's just you just need enough energy to push up the molecules, and once you get a certain amount of energy, that creates a boil once you get the right amount of energy. And all boiling is just evaporation that happens underneath the surface. So these bubbles in this thing, that's just evaporation under the surface. All right. And the last thing that makes this possible is obviously heat transfer. So what I'm going to do is I am going to hold an ice cube in my hand, and that's dripping, but basically just make the temperature of my hand colder, and we're gonna see what happens. So I got my hands are cold now. Let me get the water off. You can see nothing is happening. It's the liquid inside it is not going up at all. Nothing is happening. But then if I hold it with this hand again, you see it goes right back up and starts to boil. But then if I go back to the cold hand, watch what happens. It just goes completely back down. And that is the principle of heat transfer. You can only transfer heat from hot to cold. You can't warm something up with the cold, and that's just kind of common sense. But basically, heat can only flow from hot to cold. That's why things boil, because it's going from hot to cold, obviously. It's also kind of something we talked about in class that I really liked. The example was like when you stand on a tile, it feels colder because the heat from your body is transferring it to the tile, which makes it feel cold. So yeah, this is my experiment and just different things with heat, evaporation, and boiling.